Hello and welcome to the first of a three-part series of videos featuring a new technique of creating a lasting decorative concrete structure. In this section we're going to be exploring the mold making and casting of 4 curved GFRC panels. Then we're going to discuss using these panels in permanent architectural formwork for an outdoor bar and entertainment space. In part 3 we're going to explore a little deeper on the countertops and how they were created. Today we're going to start with Adam walking us through the mold making and casting process. Adam, how are you today?
Hey, how's it going?
Really good. So if you could, just tell us a little bit about the inspiration and how you came up with this idea.
Sure, yeah. I mean, you touched on a little bit that we're trying to make something structural, and we're going to use GFRC for that. And GFRC typically is not used for anything structural. It's usually used as a facade, maybe as a countertop.
Sure.
But in this case, we wanted to kind of create an application for it that would be a little different.
Nice.
We're going to get into that a little bit more, like you said, in part 2. But for me, we could talk about the design of the panel itself and the mold making and casting.
Yeah, let's hear a little bit about the inspiration for the design for this panel.
Sure. Yeah. When we were talking about what would look good in concrete, we kind of went back to our favorite architectural styles, and one of my personal favorites is Art Deco.
Okay.
So Art Deco is a style of architecture that was popularized in the 1920s. You see a lot of these buildings in New York. Probably the Chrysler building is the most popular. So for these panels, for our original model, we decided to borrow elements from some of these Art Deco buildings and kind of put them together to make this original model that we would then cast reproductions of.
Great. So how did you come up with the conceptual design to this finished model?
So from the conceptual design, which was this Art Deco style, we created a line drawing, and then we actually cut these all out of individual wood panels. Okay. So we wanted kind of an organic look to the whole thing. All right. So we decided to just make everything by hand and assemble it by hand. Great. So all the elements are handmade? Yeah. In previous videos, we've shown you how to make a mold of real objects. We've shown you how to make a mold of things that were cut in CNC. But in this case, we wanted to do something, like I said, a little more organic. Okay. So, yeah, each individual panel is a separate piece. Great. Now I noticed this isn't the original board here. The model's actually white. It's not the brown wood. Can you tell me a little bit about that? Yeah, that's true. The original pieces of wood, like I said, were brown. But there was some more prep work that was involved with making this piece. So those all had a bit of texture on them. They were porous, and you also had these seam areas. So what we did, a couple of different things. We put caulk into all these seams individually. We also took clay and created some areas that had some different highlights to them using the clay. Yeah, I can see that there. And because we had all these different elements, we decided to paint the whole thing with a semi-gloss white, just to kind of make a uniform texture over everything. Okay. And then prior to mixing and pouring the rubber onto the model, you used some type of sealer and release agent. Right, right. So first we built the mold box around the containment field for the rubber. And we figured there's probably still some porosity to the original, even though we painted it. Okay. And we took a little bit of sonite wax, which is a paste wax sealer, and brushed that over everything. And then we took universal mold release and sprayed that over everything as a release agent. Okay. And then we could pour the VYTAFLEX 60. In total, it was about 90 pounds of rubber for this application. Okay. And why did you choose VYTAFLEX 60 for this particular project? VYTAFLEX, the series, has been around for about 15 years now. It was a product that was formulated specifically for concrete casting. It's very durable, good for long lasting, good for exact reproduction, doesn't shrink or expand, that kind of thing. The VYTAFLEX 60 is on the harder side of that. And you use that primarily when you have these areas that aren't very deep. They don't have deep undercuts. It's kind of shallow relief. Right. So that's kind of why we chose that. Great. So the VYTAFLEX 60, basically you're able to pour the rubber and then overnight, because it's about a 16-hour demold time, so it's ready to use the next day. 16-hour demold time. Perfect. And because we prepped everything up real nicely, it really just peeled right off. Great. Okay. So now that you have these, now you have this model and you have the form liner, tell me how you actually made curved GFRC panels. Right. So when you pop it out of the mold, it's really just flat, but because it's a rubber, it's also flexible. Nice. So as part of our final design, we needed to make inside curves and outside curves, concave, convex curves. So to accomplish that, the trick was to build a casting bed that actually had those two different arcs on it. So if you had it one side facing up, you'd get your concave curve. If you had the other side facing down, then you get your convex curve. So that was kind of the trick to it. You lay the the mold on top of that, and it takes whatever shape that you set up.
Yeah, I saw you guys working on that in the shop, and I thought you were building a skateboard ramp, so I was pretty excited. But
yeah.
In fact, it was for architectural form.
Yeah, you kept saying you were going to bring your skateboard in. I didn't see
I haven't. Okay, so now you have the mold and the casting for a convex panel. Anything special about the GFRC mix design or the GFRC process when you were going through this?
Not really. It was kind of a standard GFRC mix design. The piece itself, the mix design itself featured 4-ton VF774 polymer. And that's in there to ensure maximum strength of the composite and maximum ductility. It also reduces water absorption and helps a little bit with color uniformity and the processing of the material itself. So we use Portland white cement and we use a tan iron oxide to get the color we wanted.
Okay. Now, when doing GFRC, it's typical to do 2 face coats sprayed from a hopper gun and with no fiber added, and then your backer mix. You followed that specific style?
Yeah, so you spray a very thin layer, and then you actually, we like to take a brush and lightly brush in between those 2 face coats. We'll take a brush.
Why is that?
What that does is it kind of reduces any kind of micro bubble entrapment at the surface.
Okay.
Not everybody does it, but when you have pieces like this with all these angles and details, it's good to get a very light brushing in there. Once those 2 applications are done, those 2 face coat applications are done, then you're ready to do the backer. You have to wait though 20 to 40 minutes, depending on your shop conditions, for that back side of the material to haze up. And that's something you see. You can actually tell the difference between freshly sprayed concrete and this product that's hazed for about 20 to 40 minutes.
So more of a visual and less of a time.
Yeah, okay. It's not it, again, depends on your shop conditions. So once that's hazed up, really the point of that is you don't want it to be too soft so that when you're laying in your backer, it's going to push that material out of the way, or too hard so that when you're laying in the backer, you're actually cracking the surface. Okay. So, but once you have that at that point, then you can mix up your backing material. Same mix design, you just add AR glass fiber to it, and then you build that up in several layers to reach an ultimate thickness of about 3/4 of an inch is what we were going for, 19 millimeters. Okay, great. Was there any additional support added for the panels to hold them together? So in the panel design itself, the only material that's added to the mix design is the glass fiber, but because these panels are actually ultimately going to get lashed together, connected together, we embedded anchors and U-bolts into the back of the panels. And that we're going to get into a little bit further in part 2 again. Okay. Touches more on the structural application of using it. Perfect, perfect. Now, I remember demolding the piece. It was heavy, but not super heavy. Can you tell me about how much the panel weighed? Yeah. The big panel, which would be the outside curve, was about 240 pounds. And then the inside curve was actually a little bit smaller. It was about 215 pounds. Okay. So we actually did 2 different sizes with it. Well, that's nice because you were able to use the same form liner but do two separate castings. How did you account for the difference in the size of the panels? Yeah. So we pre-planned it. So when you see the original model, you'll see there's like 7-8 inches of extra space where there's no specific detail, and that gave us room on the form liner then to section that area off, and then we just didn't spray concrete on it. Okay. All right. So that was the nice thing. We were able to use the same form liner to make both size panels, again, just flipping over that casting bed to make the other opposite curve. That's cool. So you were able to use one form liner and get 4 separate panels out of it. Right. Yeah. Excellent. Okay. So in total 4 panels, 2 concave, 2 convex, all from one form liner. Yep. And once they're all ready, then we're basically loading them up to a trailer and ship them off to the job site. Great, and that's where we're going to end this particular video. We're going to pick up part 2 with loading the panels up and taking them to the job site. We're going to speak with Kevin, who's going to walk us through the installation of this permanent formwork in a backyard for the entertainment space that we're creating. So Adam, I want to thank you very much for walking us through this, and we'll see you in part 2.